This is AP Calculus AB, section 2.2, page 1. We are talking about infinite limits. The first thing that I want to do today is to explore the limit as x approaches 5 from the left of 1 over x minus 5 via a graph. So, when we look at the graph, we see something like this. This is on a standard viewing window, negative 10 to 10, negative 10 to 10. And we see right here at x equals 5, there is a vertical asymptote here. Even though your calculator didn't draw it, there is a vertical asymptote there, and you remember that from pre-calc. Let's go ahead and sketch this graph onto paper. And we'll put that vertical asymptote in at 5. And we see this. So, again, looking at this limit as x approaches 5 from the left, coming to here's 5. At 5 from the left-hand side, we see that these y values are going down more and more negative as x gets closer to 5, so that we say this limit is negative infinity. Y can't equal negative infinity. Negative infinity is a concept, not a number, but this says that the y values decrease without bound. So as x gets closer and closer to 5, those y values get larger and larger and larger in a negative direction. How about the limit as x approaches 5 from the right of this function, 1 over x minus 5? So again, coming at 5 from the right-hand side, this time these y values get larger and larger and larger. So this limit is positive infinity. And we say, or this means, that the y values increase without bound. Again, this is saying as x approaches 5 from the right-hand side, the y values get larger and larger and larger in a positive direction. Together then, we can say the limit as x approaches 5 in general of 1 over x minus 5 does not exist, because one side's going toward negative infinity and the other side going toward positive infinity. Looking at this next one, what about this function? F of x is x plus 2 over 1 minus x squared. Let me turn this one off. X plus 2 over 1 minus x quantity squared, and I'm going to change the window here. Negative 5 to 5 in the x direction, negative 10 to 10 in the y direction, and we are looking at the limit as x approaches 1 from the left and 1 from the right. Here's the graph. Here's x equals 1 right there. Remember, x's are going from negative 5 to 5. Y is negative 10 to 10. So x is 1 is right there, right here. Let's see what happens up a little closer to 1, kind of off the screen here. So let me change that window. Let's send those y values up to, say, 20. A little closer. Let's go again. Let's go a little bit bigger still. Let's send those y values up to, say, 50. Okay, hopefully by zooming in a bunch of times or seeing that wide window, you can see that there's really a vertical asymptote sitting right in here at x equals 1. These two pieces will never touch. They'll never meet. They keep getting closer and closer and closer together, but they will never actually meet. Let's go ahead and sketch this graph onto paper. Here's that vertical asymptote at x equals 1. You hear my dogs barking in the background, I'm sorry. And this is coming up like this. This piece does cross underneath the x-axis. It does come along here and flatten out again. We'll talk about how you know that later. And we have another piece, this one over here. Like this. There's that graph. When we look at this then, the limit as x approaches 1 from the left of this function, here's 1, coming at 1 from the left. These y values increase without bound, so they head toward positive infinity. When we come at 1 from the right-hand side, again, those y values increase without bound. So that limit is positive infinity. And together, the two of these being the same positive infinity tells us that the limit as x approaches 1 in general from both sides of f of x is positive infinity. All right, the whole point of working through these two examples is to talk about vertical asymptotes and how it relates to limits. And we find that vertical asymptotes occur in the graph of a function at x equals a when the limit as x approaches a from the left side of f of x is positive or negative infinity, or the limit as x approaches a from the right side of f of x is positive or negative infinity. And it's an or in here. Both are not necessary. We don't need from the left and from the right. We just need one of them. For example, we could have a graph that looks like this. It would be a piecewise defined function, but the limit from the left side as x approaches a is positive infinity. The limit from the right side as x approaches a is some numerical value. It's not a positive infinity or a negative infinity. There is still a vertical asymptote here at x equals a. It's a vertical asymptote from the left-hand side. End page 1.